Creek State Park. My name is Heather, and so this is going to work in just a moment. Dr. Bill Busler is going to introduce his folks and then do a little presentation that'll tell you something about what's actually out there to be seen and a little bit about the star maps. And then once we finish with the presentation, we're all going to caravan kind of up to the horse trailer parking lot where they'll have the telescope set up for you to enjoy. So I'm going to turn it over to you.
Thank you, Heather. It's always a pleasure for us to be here, especially when we have good weather. We were kind of sweating it earlier today, it looked like clouds are moving in, but they kind of parked over in Oklahoma, and then just some little thin ones are coming through, which won't mess us up that much, because we've got some cloud-piercing telescopes in our group, so we can see whatever we need to see that way. As Heather said, the plan is we're going to look at some sky maps and see some of the constellations that are visible this time of year. And then we will look at some slides of the objects that we're going to be showing you through the telescopes with a little explanation of what they are. Our experience has been that if you just take people to the telescopes first, all they see is little gray smudgy spots, and one of them looks pretty much like the other. But if you have some idea of what it is, you have a better appreciation for what it is you're seeing. You can actually see more and you know what to look for. So that's our plan. And then we will, as Heather said, we will caravan over to the site north of the north campground. It's the, what is it now?
It's the horse trailer parking lot.
Okay.
It's where we set up.
Okay, word of warning about the horse trailer parking lot. Good idea to watch where you step over there. There's horses tend to do their thing. Okay, first we'll give out the sky maps. Have an assistant perhaps. Okay. They work their way back. Let me introduce the members and telescope people that we have here from Astronomical Society, because you won't see them again until we get over there and it'll be dark then. Starting here, we have Tom Richardson and Tim Harris and his son Zachary, and in the back, Richard Moore and Mark Matthews and Rebecca Love, and we have Sarita Joshi passing out star maps of her husband, and Joe Clark, who is also going to be setting up the telescope. So these are all knowledgeable people, so if you run into them over there by the telescopes, be sure to ask them any questions you have that you don't get used up while you're in here. So they're all willing to help show you what they're have lined up for you in the telescope. So now if the people who need to set up telescopes want to, you can go on over there and do that. You can stay in here as long as you want. Encourage you to do this 3 dozen times anyway. So you will join you after a while. Here, won't see anything for a while. Okay, how many of you are familiar with using sky maps? Okay, that's what I thought. It's usually the way it is. And as a result, most people are a little confused by what we have here. This represents the sky as we see it at the time shown in the upper left corner. So it'd be about the way it is around 8:30, 9 o'clock this evening. At this latitude, which is 35 degrees north. So this is pretty much the way the sky will look this evening when we go over to the observing site. The circle on the map represents the horizon all the way around. And the different directions are marked. You can see east, south, west, north around the edge of the map. Those correspond to whatever direction you're facing in the sky. Now, if you're looking carefully, you might notice that not the way a land-based map is. If you put north at the top of the map of Arkansas, for example, south, of course, will be at the bottom, but east will be on your right, and west will be on your left. Well, this is the opposite of that. The east and west are switched. That's because this isn't a land map, and you're not made to look down at it like it's on the table or in your lap in the car. It's overhead. So if you hold the map overhead, and we are facing north here, hold the map with the north in front of you, and then south will be behind you, and the east will be to your right, and the west will be to your left, which is the way it is in the sky. So that's why it's switched from what you're probably used to on the road map. Okay, the map shows all the bright constellations that are visible this time of year, and many of the bright stars that we can see. The constellations are all capital letters on the map. You hold the map with the east side down. This is the way things would look if we were facing towards the east outside. See, just over the word east and up to the right a little bit, you'll see the constellation Virgo. And a little to the left of that, the constellation Boötes. So those are the constellations with all capital letters. The bright stars, of course, start out with capital letters because they are proper names, but then switch to lowercase. In the constellation Boötes, you can see the star Arcturus. And in Virgo, you can see the bright star Spica is labeled. Now, not all the stars are labeled, not even all of them have names. Some of them just have numbers or letters. But all of the important stars are labeled with their names on the map. If you were facing towards the north again, you don't need to hold it up over your head because you can't see the whole sky at once unless you were a fly, I think. I think they can do that with their compound eyes. But since you can only see a small portion of the sky at any time, just hold the map with that side down, whichever way you're facing. If you're facing north, hold that side down, and you'll see the constellations Cepheus, Cassiopeia, Draco, Ursa Minor, and Polaris, the North Star, right there in the north. So if you turn around towards the west, over the western part of the sky, you'll see some of these familiar winter constellations, ones that you've heard of, like Orion, for example. He's setting over in the west. And Taurus, the bull, just to the right, bright star Aldebaran. Now, what isn't shown on the sky map are the planets. Because by definition, planets wander around. We just have to remake the map every couple of weeks. So the planets aren't on here, but let me tell you where two bright planets are tonight. One of them is Venus. I'm sure you've been seeing it over in the western sky the last few weeks. It's the brightest of all the planets. It's brighter than anything in the sky except for the sun or the moon. And it's in the constellation Taurus, very close to the star Aldebaran. It's just moving around in that area. And since it's kind of close to the western horizon, that's the first thing we're going to look at when we get over there before it slips down behind the trees. In California, they started to get worried about that. They think they've seen a UFO. And I've seen reports where a lot of people are very concerned that there's this UFO out in the western sky in the same place every night for about the last month or so, and they're getting deeply concerned about that. But that's California. Another bright planet is Jupiter, and it's up near the constellation Leo, between Leo and Gemini. If you go right back near the middle of the map, you'll see the constellation Leo and the star Regulus. Well, the planet Jupiter is in that area next to the little dim constellation of Cancer, the Crab. It's way brighter than any of those stars around there, so you won't have any trouble seeing it. It's nearly overhead when we go out. The very bright thing overhead those evenings is Jupiter. And we'll see some pictures of that later on. Let's see what other interesting things we need to look at. The Big Dipper is well placed for observing this time of year. You find that? Hold the map with the north side down, or actually it's permissible to turn it at an angle and have the northeast side down. Just have the northeast corner down. Come up a ways and you see the constellation Ursa Major. Well, Ursa Major means the larger she-bear. That's a very big constellation, but part of it is the Big Dipper. Did you find that okay? Everybody find the Big Dipper on the sky map. That's the 7 bright stars. Yeah, if anybody's having trouble finding there, we've got expert help over here. Rebecca makes sky maps, so she can find anything.
Scissors.
Okay, the Big Dipper is very useful for finding other constellations. If you find the Big Dipper, that's no problem because it's very high in the northeast and it's made up of 7 very bright stars. You'll see it as soon as we get out there. And I have a nice pointer that I can show it to you if you're having any trouble. If you look at the map with the north side down, look at the bowl of the Big Dipper. And you see those 2 stars on the left side. Those are called the pointer stars because they point pretty close to the North Star, Polaris. Not exactly right at it, but about as close as you would need. If you find the Big Dipper, follow those pointers down this time of year towards Polaris, that will tell you pretty much within a fraction of a degree which way true north is. Better than a compass, actually, because they point to the magnetic north, and that's off by quite a bit. And Polaris is within a fraction of a degree of being straight north. And it's always there, every night of the year, all night long. Now, that's kind of a strange thing. It's the only star that doesn't seem to move around. All the others rise and set and circle around Polaris. The reason for that, once you understand it, is pretty simple. That's because it's directly above the North Pole of the Earth. Or another way of putting it, the Earth's axis points right at Polaris. So as the Earth turns around, it's like being on a merry-go-round and looking straight up, and the trees and things right above you don't seem to be moving because that's the axis of the thing, and you're turning around. If you look out to the side, everything moves around, but the thing straight up above you holds still. So if we were at the North Pole, Polaris would be straight overhead, and all the other stars would be circling around it. Well, of course, we're not at the North Pole. We're at 35 degrees north of the equator here. But the same rule holds true. The Earth's axis is still pointed towards Polaris, so it holds still. And as the Earth rotates towards the east, all the stars appear to rise in the east, move across the sky, and set in the west, just like the sun does in the daytime, for the same reason. I think a lot more people know that than know that the stars move across the sky at night. Everybody's used to seeing the sun rising and setting, but the stars keep doing it at night. The Earth doesn't stop turning. It took me a while to learn that when I was first getting started. So the pointers point to Polaris, the North Star. Now, at other times of the year, the Big Dipper can be in other parts of the sky, generally in the north, but not just right where it is tonight. But the pointers always point to the North Star. So on any clear night, you can tell which way north is. Now, the Big Dipper helps us in other ways. Let's go back to the handle of the Big Dipper, right where you see the words Big Dipper. You follow the curve of the Big Dipper's handle backwards from the bowl out towards the tip of the handle and keep going in a curve. It will lead to the bright star Arcturus, low in the eastern sky. Everybody see Arcturus? You see how the handle of the Big Dipper points towards it. Now, I'm going to tell you something kind of silly here, but it has an upside to it. We say, follow the arc to Arcturus. It's corny, but if it helps you remember the name of at least one star, you know more than most people. So there you go. Follow the arc to Arcturus. And while we're at it, it gets worse. Speed on to Spica. So follow the arc of the Big Dipper's handle to Arcturus and keep continuing that same curve along across the sky, and you'll come to Spica. Now, Arcturus is a very bright orange colored star, and Spica is a blue star. Did you all know that stars come in different colors? Now, they're not like Christmas tree lights or traffic lights. They're not brilliant colors like that. They're sort of pastel tints. But if you look at them closely and carefully, especially looking back and forth, say between Arcturus and Spica, you can easily see the difference in colors between them. Does anybody know what the different colors of stars indicate to us? Yeah? Yeah, heat, the temperature. The hottest stars, like Spica, are bluish in color. And the dimmest ones, or the coolest ones, are the reddish looking ones. Now, I haven't shown you a red star yet, but if we switch over to the western side of the sky and look at Orion, we'll see another bright blue star, Rigel, down in Orion's foot. You see the 3 stars in a row, the Orion's belt, and then up in his shoulder, Betelgeuse. It's a red supergiant star. It's relatively cool. Now, you wouldn't want to stick your hand in it. It's about the same temperature as glowing charcoal in a fire. In fact, the colors of stars indicate temperatures pretty much like the flames that we're familiar with. Glowing dull red is the coolest, getting a little brighter orange, yellow, like a birthday cake candle. That's still hotter, yellow like that. Then white hot, and finally blue for the hottest ones, like a acetylene welding torch. So if you know that already, that tells you about the temperatures of stars and how hot they are. So there's some Betelgeuse. Oh, I'll tell you about how big it is. Did I say it was a red supergiant? You know what the solar system looks like, right? The sun, and then the 4 inner planets, Mercury, Venus, Earth, and Mars, and then a little gap for the asteroid belt, and then Jupiter, Saturn, Uranus, and Neptune. Now, Betelgeuse is such a huge star that if you put it in the center of our solar system instead of our sun, Mercury, Venus, Earth, and Mars would actually be inside it and would be reaching out to the asteroid belt almost out to where Jupiter is. So it's several hundred million miles in diameter. That's one of the largest known stars. Let's see what else we've got of interest there. Castor and Pollux, the twins. Let's look over to the west again. Look up about 2 inches from the western horizon, and we see 2 bright stars side by side, Pollux on the left, Castor on the right. Those were the mythological twin brothers. They're usually shown with their arms around each other. And down at Castor's foot, you'll see a little circle of dots called M35. In fact, you'll see lots of little things on the map marked with an M. See just to the right there in Auriga, 36, 37, 38, 42, and 78 in Orion. All those little things with an M have kind of an interesting story. M stands for Messier, Messier. Looks just like Messier. But Charles Messier was a French astronomer who lived about the same time as George Washington. And he was a comet hunter. And he thought he would make his mark in astronomy forever by discovering comets. And all while he was alive. And that's in fact what he did. He discovered quite a few comets, more than anybody else had up to that point in history. But none of those comets are still visible anymore. But every now and then he would discover a little fuzzy spot and think it was a comet, and it would turn out to be in the same place every night. Well, comets aren't like that. They're members of the solar system, like planets, and they wander around. So if something was in the same place every night, it wasn't a comet, and he'd have to tell everybody, never mind, that wasn't a comet. So finally, one night, he got tired of that going on, and he decided to make a list of all of these little fuzzy spots in the sky that weren't comets, so he wouldn't get confused by them anymore. And so we have a list of 110 of these deep sky objects that Messier cataloged, which we spend most of our time looking at as amateur astronomers. So sometimes you have good plans and good intentions and they don't work out, but something even better happens. So Messier thought he would be forever known as a comet hunter, but now what he's known for is his list of things that are not comets. And so he lives on that way. So we'll look at some of those through the telescope, and you'll see what a catalog of wonders it truly is. The brightest star in the sky is still visible. A lot of people think the North Star is the brightest star in the sky, but it's really about 26th in line. The brightest one is Sirius, the dog star. You found it on the map? Yeah. Over in the southwest. Orion's belt points to it. There's nothing else quite like Orion's belt in the sky. 3 bright stars in a row. And if we follow that to the left, it leads pretty close to Sirius, and that's the brightest star in the sky. Let me tell you a little bit about the magnitudes of stars. You've heard that term? Magnitude, it just means brightness. And the numbers are a little bit confusing. The first magnitude stars are the brightest ones, and on down to the faintest ones you can see are 6th. And you may think that's backwards, the bigger number ought to be brighter, but think of it as like a prize in a fair. You got first prize, second prize, third prize, and so on. So the first magnitude stars are the brightest. Venus, by the way, is so bright that it's brighter than first. It's about -4. So we have to set up a special extension of the scale for something as bright as Venus is. Let's see, we've got Sirius, Regulus, Leo. Did anybody bring binoculars? Well, some of us have got some. And if you have them or in their car or something, take them to the observing site, because there are a lot of things you can see with binoculars. You don't need a telescope, and you can see a lot of these things at home. One of the most beautiful things this time of year is very high in the western sky. Remember where I said Jupiter was, near the constellation Cancer, the crab? Just Regulus and Leo is almost directly overhead. Jupiter's right next to it. And then going down to the west towards Castor and Pollux, right in between there, Cancer, the crab. You see where it says M44? That's one of those Messier objects. It's a cluster of stars, and it's really near us. It's so big that you can easily see it in binoculars. And in fact, it won't even really fit into the eyepiece of the telescope. You have to move back and forth to see it all. So that's something that's called a beehive cluster, because you have a good imagination. It kind of looks like a swarm of bees sitting there. So those are some of the more interesting things in the sky. One more thing I want to talk to you about, and that is the dotted lines on the map. You see one on the east? It comes up right over the word east. Equator. Dotted line goes all the way down to the west. That divides the sky into the northern and southern halves, just like the equator of the Earth is the boundary between the northern and southern hemispheres. The celestial equator, as it's called, divides the sky into 2 equal halves. And it's just the opposite of the poles. Polaris is at the north celestial pole. The equator is right in the middle. We don't get to see the south end of the sky from here. You have to go into the southern hemisphere to see it, down to Australia, for example. The other dotted line is called the ecliptic. And if you look at the constellations along the ecliptic, let's start over here in the west. Taurus, Gemini, Cancer, Leo, Virgo. Those names sound familiar? Yeah, what are they? Those are the constellations of the zodiac. And what's the link there? Well, there are 12 of them all the way around the sky. The ecliptic is the path of the sun around the sky during the year. Of course, it's the Earth going around the sun, but where we are, looks like the sun's going around the sky during the year. And that's its path. Now, since the solar system is a big flat disk, it's not all helter-skelter, but everything's in the same flat plane, all the other planets and the moon also follow the ecliptic. Very close to it. So whenever you're looking for any planet or the moon, you don't generally have to hunt for the moon or the sun. They're always going to be in one of those 12 constellations along the ecliptic, known as the constellations of the zodiac. And since there are 12 of them, the sun spends about 1 month in each one of those constellations going around the sky during the year. Some of the planets are very slow moving. They may spend 10 years in each constellation. Ones like Mars go around the sky in about a year and a half, so they're every couple of weeks they're in a different constellation, but always along the zodiac, ecliptic. You'll never find Venus in the Big Dipper, for example. It's always, and where I say it was tonight, in Taurus, right next to Aldebaran. So that illustrates that point. Okay, does anybody have any question about that before we look at the slides of the objects we're going to see this evening? Okay. Yeah. For once it didn't let us down.
Usually it's turning itself off for the rest of the
Or it comes on the thing won't update.
Yeah.
Does this
No, you'll have to use the arrows.
on the computer itself? Oh, okay. So this doesn't really do anything.
No, it only does if you plug into them.
Okay. Well, that's fine. We call this presentation here Our Place in the Universe because we start out nearby and we work our way out to the farthest reaches of the universe in just a few minutes. Since you all were all up close here, sometimes I do this and we have to look at all the stuff on the sky map on the screen, but you all have got it in your hands and we don't really need to do anything with those. There's the following the Arcturus and speeding on despite the red arrows on there. Just had to put that on there. Okay. Well, here we are. Our Earth. Let me get the lights on. Where's we can just go from back.
Yeah.
Right. Well, that helps some. I want it completely dark. This is one centered on the United States. Most of them you see are on other parts of the world. How do you do that?
There's different controls
Oh,
on that.
okay. Well, that's ideal. Thank you. Okay. We are just about here, right under that little cloud right there. This is usually the case. Does anybody know what that is? No, not a black hole. It's a planet. It is. That's Venus. It's kind of looks like the AT&T had a little bit of it. The thing that hangs in a window at the globe with the stripes on it. Well, that's the planet Venus, and it's a beautiful planet. It's kind of like the twin of the Earth, just a little bit smaller than the Earth, but it's quite a bit closer to the sun than we are, and it's got an interesting atmosphere. Part of it is carbon dioxide, and part of it is sulfuric acid vapor. And those combine and make little droplets, and it's always covered with clouds, even worse than here. It's extremely hot due to the greenhouse effect. The sun lights it up and heats it up, and the heat that's generated on the surface can't escape. So it's always several hundred degrees on the surface of Venus. It doesn't look very interesting through the telescope. We're going to show it to you anyway because, you know, it's up there and you probably all say you've seen Venus through a telescope. But since it's covered with clouds, we don't see any details on the surface. For some reason, it's just stopped. Okay. All right, what about this one? What's that? Mars. Yeah, that's the red planet. You can easily see the reddish color and some of the greenish color as well. They used to think many years ago that that was some kind of vegetation that changed with the seasons, sort of like on Earth. But it's not. They're just different oxides of iron. Some of them are red colors, some of them are greenish color. And notice it has a polar cap, and it's made out of carbon dioxide, frozen, like dry ice. In fact, that's the same thing as what dry ice is frozen carbon dioxide. It's pretty cold up there. It can get up to almost shirt sleeve temperature the very hottest time of the day and the hottest time of the year, but most of the time it's like Antarctica. Not a good place to visit either. In fact, there aren't any good ones in our solar system, other than here. What's this?
Jupiter.
No, no, I heard it right there. It's, hold your thought. We'll get back to you. This is Jupiter, the largest planet. It's about 11 times the diameter of the Earth, about 88,000 miles across. And if you look at the picture, not sure you can tell, it doesn't look totally round, does it? It's kind of squashed. It's a little wider through the equator than it is top to bottom. Sort of like me, it has an equatorial bulge. The reason is that it rotates very rapidly. In only 10 hours, its day is only 10 hours long, and it's really big, and it's not solid. It's gases, maybe some solid frozen hydrogen or something near the center, but it's basically a big gas ball, and when it spins around that fast, it just kind of flattens itself out a little bit. So you'll notice that. There's also a perpetual storm on it that is known as the Great Red Spot. Sometimes it's bright red, sometimes it fades out. A few years ago, it disappeared altogether, but it came back in the same place. So depending on which way it's aimed tonight, we could well see the Great Red Spot on Jupiter. Another thing you'll see when we look at Jupiter is it has 4 bright moons that were discovered by Galileo the first night he was using his newly set up telescope. And he noticed that night after night they kept circling around Jupiter, one side and the other, front and back. And he said it's like a miniature solar system. And that gave him some good insights as to how our solar system actually was put together, looking at Jupiter as being like a miniature solar system. Now, Saturn, yes, the one with the rings. And it won't be up till kind of late this evening. We'll stay out there as long as you want, but it won't be up till around 11 o'clock to get above the trees. But if anybody's here then, I'll be glad to show it to them. It's the only planet with a big system of rings like that, although it turns out Jupiter, Uranus, and Neptune also have thin rings that are just barely detectable. But this is certainly one of the most beautiful things in the heavens. It's thought to be where some moons would have formed, except that the gravity from Saturn was so strong and gradiented over that area that nothing solid could come together. So all the little particles that would normally form into moons just stay as separate particles. They're so thin, only a few miles thick, that at that distance, nearly 1 billion miles, when we see it edge on, sometimes we do see the rings edge on, they almost totally disappear because they're just paper thin compared to the size of Saturn. Okay, our galaxy, the Milky Way. We live in a galaxy. A galaxy is a big spiral pinwheel-shaped group of stars. In this picture, we're looking at it edge on. How many stars? Well, about 100 billion. Nobody's counted them all. There has to be an estimate of it. But there are probably about 100 billion stars in our galaxy, one of which is our sun. The sun is a star, one of the 100 billion. And you can see that we're out near the edge, about 1/3 of the way in from one side. And it's kind of a lens-shaped thing. It's about 10,000 light years thick, 100,000 light years across. Haven't used that term yet, have I? A light year is the distance that light travels in a year. Well, how far is that? If you do a little arithmetic, you know that light travels at 186,000 miles per second. Most people know that, or maybe the metric version, 300 million meters per second. Well, if you multiply that by 60 seconds in a minute, and then 60 minutes in an hour, and 24 hours in a day, and 365 1/4 days in a year, you'll see how many miles a beam of light can travel in a year. And it's about 6 trillion. So 1 light year is a measure of distance, about 6 trillion miles, how far light can travel in a year. The stars on our star map are generally hundreds of light years away. Spica, Rigel, Betelgeuse, about 600 light years away for each one of those. So when you look into the sky, you're seeing them as they were 600 years ago. Well, shoot, when you look at anything in the sky, you're not seeing it as it is, even the moon, right? About 1 1/3 seconds before, it's 250,000 miles away. It's not instantaneous. When we used to have astronauts up there, we would have conversations with them. We'd say, how are things going? And it would be just, okay here, how about there? Click, click, and then another few phrases. And it wasn't because they were slow with it or anything. It's just that the speed of light, as fast as it is, isn't instantaneous. And even our nearest neighbor, the moon, we don't see it as it is. We see it as it was a little over a second ago. The sun, about 8 minutes. So when you're looking at the sun, you're seeing light that left there 8 minutes before. When we look at Saturn, about an hour ago. So we see Saturn about an hour, and we see most of these stars like they were hundreds of years ago. Now, our galaxy, 100,000 times 6 trillion miles across. 10,000 times 6 trillion through the middle. Pretty big, isn't it? Yeah. For a long time, well, I'm going to do a face-on view. Picture of the Milky Way, you can see kind of the spiral structure of it. I didn't make 100 billion little dots there, but you get the idea. There's lots of little stars in there, one of which is the sun. Here's another artist's conception. This is a drawing. We can't take a picture of the whole Milky Way, can we? Just like if we were locked in this building, we couldn't take a picture of what it looks like, just inside. You got to get outside it, or look at another building around, and then you can see kind of what it looks like. So this is probably what our galaxy looks like. Spiral structure because it's rotating, and all these little red spots we'll see are where new stars are being formed. And we'll take a look at some of those through the telescope. In the western sky, in Orion, below Orion's belt, 3 stars, you'll see one of those Messier objects, M42. This is it. You can tell with your naked eye that it's not a point, it's not a star. And if you look at it with binoculars, you can see that it's fuzzy. And when you look at it through a big telescope, this is what we see. This is a place where new stars are being formed out of this gas and dust. So stars form all the time out of gas and dust clouds called nebulae. So this is one of the things, if we can catch it through the trees, we'll see it. Otherwise, we'll look at one on the other side of the sky. Here's one in Sagittarius, the Lagoon Nebula. That looks like a monster of some kind, a couple of eyes there and a glowing brain. This glowing brain part is where the new stars are being formed. Here's a cluster of stars kind of in the foreground. And all this glowing reddish stuff is mainly hydrogen gas that's going to forming the new stars. Here's one of people's favorites. This is the Pleiades. It's a cluster of stars known as the Seven Sisters. So it's on your star map. Well, I think it is. No, it's just, it would be right on the northwestern horizon. It just didn't make it. It was on the March map, but it's not on this April one. But it's a cluster of new stars. They're hot and bright and blue, and you can see the gas left over from the formation of those stars. If the shape of it looks a little familiar to you, like the Subaru emblem, that's because it is. Subaru is the Japanese word for the Pleiades, the Seven Sisters, and they adopted the Seven Sisters as their emblem, so it's on all their cars. Here's the Beehive cluster I was telling you about in Constellation Cancer, right in between Leo and Castor and Pallas. In fact, very close to Jupiter. When we're looking at Jupiter, we can just kind of go back and forth a little bit and see the Beehive cluster. Very beautiful thing. There's another star cluster, globular cluster. It's made up of about 1 million stars, probably. This one is M13 in Hercules. If you look at the map with the northeast corner down, you see where Hercules is, and right in one of the edges of the square in the center of Hercules is M13. This is what it looks like. If that one's down in the trees, there are 2 or 3 others that we can look at. So we've got several other globular clusters we can show you. Just promise not to try to count them while you're looking through the scope. There's 500,000 to 1 million stars in one of these things. Now here's an interesting thing. Nebula is the Latin word for cloud. And this is a little gas cloud, M97, in Ursa Major, near the bowl of the Big Dipper. It's not on this map, but it's just, if you're holding the map up and the pointers are on your left, it's just above the bowl of the Big Dipper. This was caused by a star, like the sun, that got near the end of its lifetime and expanded really big in a hurry, turning into a red giant, and then sending its outer surface layers just coasting away. It expanded so big that it just lost all the material in its surface. That's the star that did it right there. And it cast off this spherical shell of gases around it, and a couple of little dark spots in it, gives it the impression of an owl face, so that's why it's called the Owl Nebula. This will happen to our sun one day in about 5 billion years. The sun is about 5 billion years old now. Its lifespan is calculated to be 10 billion, so we're just about halfway there. And it'll expand, get so big that it'll pretty much boil everything off of the Earth, and then it will send out this little shell of gases and look just like this. Every now and then, a really big star explodes at the end of its life. In the year 1054, Chinese astronomers saw a star in Taurus get so bright that it could be seen in broad daylight for several weeks. And they carefully recorded its position. And then later on, after the telescope was invented, we look back at that same place, and this is what we see now. This is the first one on Messier's list. He must have looked at it 2 or 3 times and thought it was a comet. So he led his list with M1, the Crab Nebula in Taurus. And it is on your map. If you turn the west side down, see where Taurus is, right at the left end of the top of the constellation, you see the little circle with M1 by it. And that's what this is. And we'll either show you that one, or we've got a backup one in another place in case the trees get in our way. Everything we've looked at so far has been in our own Milky Way galaxy, relatively close by, a few thousand light years away at the most. Did you ever think a few thousand light years would be relatively near? Well, here we have some other galaxies. The Milky Way used to be called the galaxy, like it was the only one. But in about the 1920s, astronomers began to realize that these little fuzzy spiral things in the sky were actually other whole galaxies like our Milky Way. And they were so far away that they just didn't look very big, even though they're as big as our own galaxy. This one is about 5 million light years away, which means it's one of the nearer ones, by the way. It's in the Big Dipper and maybe one. And when we look at that, we're seeing it as it was 5 million years ago. So we're looking back in time before there was anybody here to see it. And the light that's leaving that galaxy right now won't be here for another 5 million years. Who knows if there'll be anybody here to see it then. So things to think about when you look back in time in astronomy. We'll show you like this too, because right next to this galaxy is another one that we're seeing edge on, and it's got some star formation going on in it, and lots of debris shooting out from it. If you squint down where you can just barely see, that's kind of what it looked like through the telescope. You'll see this, it's kind of like a cigar there, long and narrow. You may or may not see that depending on how dark it is. But they're companions, very close to each other in the sky and in actual space. They're both about 5 million light years away. Here's another one we'll look at, M51. It's a double galaxy. It looks kind of like a comet in a telescope. And it's one galaxy attached to another one. We don't know whether they were formed that way or whether 2 of them ran into each other and merged together. We don't really know. Now here's the cluster of galaxies It's about 25 million light years away. And notice an interesting thing, when we start looking at these farther and farther away, we see more and more of them. And these little dots in here are Milky Way stars in the foreground, but we're starting to see about as many galaxies in the background as we see stars in our own galaxy in the foreground. That's kind of a scary thought, isn't it? There must be an awful lot of galaxies out there. Well, when the Hubble telescope was put into orbit, they decided to take a look at some area where there were hardly any stars in the Milky Way in the foreground. And here's a picture. Those of you up front can see there are 3 Milky Way stars in the picture. There's one here, and that's cheap. There's 3 of them in there that are stars in our galaxy. Everything else in that picture is a galaxy way, way off, like more than 1 billion light years away. So we're looking way, way back in time. But that's what you do in astronomy all the time. You look at the moon, you see it as it was a second ago. You look at these galaxies, you see as they were 1 billion years ago, which is unique in all of science because we can see how things develop. The whole life cycle of galaxies and the universe we can tell by the farther away we look, the farther back in time we can see. So we can get a picture of how everything happened. And the more you study about that, the more impressed you leave with the universe and creation and all of that. It's really humbling to see how all this works out. So, does anybody have any questions about any of these things before we go look at them through the actual telescopes? Anybody have any questions about these or any other astronomy topics that might be on your mind? Don't be bashful. We'll come here twice a year, so if you think of something later, you have to wait 6 months. Anybody? Yes?
Looking at the planets. When I was in school, Pluto was considered a planet.
Right.
What happened?
Well, it probably shouldn't have ever been counted as a planet. Percival Lowell and several others had been predicting and calculating where a planet should be, and there was finally a little speck discovered kind of near where it was calculated to be, and up till then, there had been 2 planets calculated and found, Uranus and Neptune, from their effects on other planets. So they were kind of on a roll and decided to call them planets. However, it's very small. The shape is not really regular. It's out of the plane of the solar system. Remember how I said all the planets follow the ecliptic and it's all a big flat disk and moves around the sun in the same direction? Well, Pluto is real catawampus from that. It could well have been an escaped moon from Neptune. And part of the time it was closer to the sun than Neptune. Part of the time it was out farther. It just didn't follow any of the rules of the planets. And then they started finding more and more of these Pluto-like objects, and this is going to get out of hand. We better just cut off calling them planets, and in fact, go back 70 years and deplanetize Pluto. That upset a lot of people, but really old people didn't know Pluto either as a planet because it hadn't been discovered then. So that's the story on Pluto in a nutshell. Yeah. Why is it called the Milky Way? Because it looks like a band of milky white light across the sky. It's sort of like you got a black tile floor and you spill some skim milk on it. It looks a whole lot like that. And the stars in it are so far away that we don't see them as individual dots. It's just like seeing the globe from a city way off in the distance. Like if you go out to the observing site, you can see a globe down from Forest City, another one from Wynne. You don't see the individual lights, just kind of glow off in the distance. And that's all these billions and billions of stars that are so far away and just blur together. The ancient Romans called that the Via Lactea, the Milky Path. And we just kept that name. Good question. Anybody else?
What time of year is the band of the
All year, but most prominent in the summer. because during the summer, the nighttime side of the Earth is facing in towards the center of the galaxy, where most of the stars are. Remember, we're out near kind of one edge. If you look in towards the center, you can expect to see more stars in that direction than out towards the edge. And that occurs during the summer. Scorpius and Sagittarius, that's where it's the brightest and big, puffy, glowing clouds. You can see it all winter, though, through Auriga and Orion, if you're in a dark enough spot, but it's not nearly as spectacular. Another good one. Anybody else? Yeah.
What is the double cluster?
The double cluster is one of those star clusters that Messier didn't record for some reason. It's two of them side by side. If you look at it through a telescope, it just looks like two star clusters side by side. They're probably close together in space, actually, too. May have been a nebula that formed into them and just kind of separated into two pieces. And each one of them became a cluster of stars. Anybody else? Yeah. What does it do? It just floats around the sun like the other objects in the solar system. It's leads a pretty dull life. It's 4 billion miles from the sun. It's cold as all get out, and it's dark because 4 billion miles away from the sun, it doesn't get much light. So it's a pretty desolate place. You wouldn't want a vacation there. Not even one night, no. Yeah. Right. Right. Of dozens that are kind of waiting to decide what to do. Yeah. Some of them are, yes. Yeah. But if you check the sizes out, you've got the 4 terrestrial planets, the Mercury, Venus, Earth, and Mars, that are stony, rocky, basically, with a little thin atmosphere. Then you've got the big gas giants, Jupiter, Saturn, Uranus, and Neptune. Then you've got some, what amounts to little leftover chunks of stuff from the formation of the solar system, and those are the ones that are the dwarf planets. Yeah. Kuiper belt objects and other things like that we don't have time to go into. What say we just go take a look at these things? Okay?